What's your YouTube name?
I don't know.
What's gonna subtract?
Probably L. Bennett. All right, so today we're looking at adding, subtracting, multiplying, and dividing functions, which we kind of already did in chapter 6 anyways, but we're just going to see different notation. But the new thing is we'll be looking at the composition of two functions. So the composition of two functions is when you combine them, and the output from the first one becomes the input of the second. This is called a composite function. I don't know why it won't let me move the boxes with my finger, but it won't. So basically you're taking a function and you're going to put it into another function. If you think about two little Easter eggs, like you get when you play the Easter egg hunt, if you were to take one that's smaller and put it inside the bigger one, that would be taking something and putting it into the other one. We're doing that with functions though. So what it will look like is this, f parenthesis g parenthesis x, and then close your parentheses twice. That's when you have two functions, f of x is one of them, g of x is the other function. So what you're doing essentially is taking the g of x function and plugging it into the f of x function for x. And that we'll use different letters, but that's just two examples of function notation. All right, the adding, subtracting, and multiplying can be written as one of two ways. You can see it in parentheses, f plus g, and then it'll have x separately. That can also be written as f of x plus g of x. You need to be comfortable with seeing it both ways. Subtracting, f minus g, and then x can be expanded out to be f of x minus g of x. The next one is multiplication. So that would be f of x times g of x, which sometimes we'll need to FOIL. Okay, if we were to have like a binomial times a binomial or so on. And of course the division will be f of x divided by g of x. Now a lot of the questions will ask you to also state the domain of the function. Okay? Remember, the domain of a function is typically all real numbers, where you can write the r, or you can do negative infinity to positive infinity. If you guys remember in chapter 5, we just always wrote that as the domain. But there'll be a couple exceptions, okay? If you have a denominator, the denominator is not allowed to be 0 because you would get a divide by 0 error. So whatever is in the denominator of the fraction, you will just tell me that that function cannot be 0. So g of x cannot equal 0. It could equal any other number, it just cannot equal 0. So that would be a restriction on the domain. So have a little side note about domain down here. The domain of all polynomial functions is the set of real numbers, which again, whenever we write this on our paper, it looks like that. Or you can also do negative infinity to infinity if you prefer. But there are a few exceptions to this rule. The first one, you cannot have a negative number under an even root. Okay? So for example, if you had this function, you will tell me that the radicand, which is the expression under the root, cannot be negative. So how can we read that using an inequality symbol? We want it to not be negative. We want something not to be negative. It could be 0, and it could be any positive number. So what kind of inequality symbol could we use? Say the radicand has to be what? Greater than, less than, greater than or equal to, less than or equal to what number in order to be positive? Jeremy? Yes, radicand has to be greater than or equal to 0. So in this one, the radicand is x plus 3. So you would say x plus 3 has to be greater than or equal to 0. And then you actually solve for x. So subtracting 3 on both sides, your domain would be that x has to be greater than or equal to negative 3. So the domain would not be all real numbers. It would be that the values have to be greater than or equal to negative 3. The second exception we talked about above is that you cannot have 0 in the denominator. So if you have a fraction, you'll tell me that the denominator cannot equal 0. You will identify what's in the denominator. Tell me that it cannot equal 0. And then solve for x. So adding 4 to both sides. So usually for domain, you would tell me all real numbers except x cannot equal 4. So the domain can be any number that possibly exists in all real numbers, it just cannot be 4. But I will tell you, 95% of the time when I ask you for the domain, it'll just be all real numbers, because most of them don't have a square root and don't have a denominator. And if that happens, you just say all real numbers. All right, they've asked us to perform each function operation and simplify, state the domain. So the first one says f plus g of x. So we can rewrite that as f of x plus g of x. You're not distributing the x per se, but some of you will think of it like that. That's how you can expand it. And we look up, the function they gave me for f of x is this. Whoops. We plug in the two functions they gave us for f of x and g of x. Now when you're adding functions, you're really adding the two functions together. You could distribute a positive 1, but nothing changes, right? So all you're doing is combining like terms, essentially. So x squared has no like term, so we'll bring it down. We have a negative x and a positive x, which would get me 0x, or you could leave it off. And 3 minus 7 is negative 4. So this would just be x squared minus 4. Notice for the domain, do we have a square root? Do we have a denominator? So the domain is all round numbers. The next one is subtraction. Notice the order switched this time. It's g of x minus f of x. Now for the minus, you do have to be careful because you'll have to distribute a negative. So g of x is x minus 7. F of x is x squared minus x plus 3. So just for subtraction, the order matters, and you have to make sure you distribute your negative symbol. So that'll get me a minus x squared, a plus x, and a minus 3. Everything in the first parenthesis stays as is. And then we'll combine our like terms. Let's always write it in standard form. Remember, descending exponent order. So I would put my negative x squared first. We have 1x plus 1x, which would be plus 2x. And we have negative 7 minus 3, which would be minus 10. Again, domain, no square roots, no fractions, all real numbers. Now example C has multiple things going on. It has negative 3 times g of x plus f of x. So we're going to take our negative 3 and multiply it by g of x, which was x minus 7. Make sure you use parentheses. And then we're going to add to that f of x. I'd like you guys to simplify the following and state your domain. Perfect. So again, about 90% of the time, 95% of the time, you're going to get all real numbers. Just worry if you have a denominator or a square root, which we will see a couple in the notes today. All right, flipping to the back, we have multiplication and division. So we have two different functions this time, and pay attention on the homework, because if the directions change and you have a worksheet, right, they'll change the functions for each direction set. So perform each function operation and state your domain. So first one, we have a little times sign, so we'll break this up into f of x times g of x. And we'll plug in the functions. F of x is x squared minus 25. G of x is x minus 5. So we have a binomial times a binomial. How do we multiply those? What? I will warn you on the homework, you may have a trinomial times a binomial, which is like FOIL, but you have to do more of your arrows, which we did in chapter 6. But x squared times x would get us x cubed minus 5x squared minus 25x and plus 125. You actually don't need to combine any like terms there because that's it. What will our domain be? Come on. All real numbers. No denominators and no square roots. Next one we have f divided by g of x, which can be rewritten as f of x divided by g of x. Now we did this back in chapter 5 where we simplified rational expressions. So first fill everything in, x squared minus 25 over x minus 5. What I'll see the mistake is that you guys will start using your exponent rules. You'll be like, oh, 2 minus 1 is just x to the first. But remember, you're not allowed to do that when you see a plus or a minus in the term. This is really a binomial and a binomial. So you need to use parentheses. You're only allowed to cross things off or simplify the top and the bottom if they are matching binomials. Okay? So the top is a quadratic. We will factor that quadratic. X squared minus 25 factors into what? Becker? X plus 5 and x minus 5. In the denominator, we can't factor that. That just stays x minus 5. Now you'll see that we do have matching binomials. We are allowed to divide those out because right now, this is multiplication and this is division, and those undo one another. So you can cross off that whole term. So the final answer is x plus 5. But our domain is not going to be all real numbers. We're going to have an exception. Make sure you don't look at the final answer when you're doing domain. When you're doing domain, you want to think about the original when you plug the stuff in before you simplify. Okay? So the domain will be all real numbers, except what? Yes. The denominator, which was x minus 5, cannot equal 0. So you add 5 to both sides and you'll get that x cannot be positive 5. If it was 5, 5 minus 5 would be 0. It's undefined at that point. Now the next one, they have g of x, they flip them around. So if I were you, I would go back to this part and just flip them because you already factored. On your homework, sometimes you'll see that same thing. So we would get x minus 5 in the top this time. In the bottom, we would have our x plus 5 and x minus 5 because we factored it in the last problem, so don't bother refactoring it on your own. So this time, we'll still have things dividing out, but our answer should be 1 over x plus 5. When you divide things out of the numerator, there's always a 1 placeholder. Okay, now our domain is all real numbers except what? Colton? -5 is one of them, and 5. Remember to look at the original denominator. So you have 2 restrictions. You say that x cannot equal 5, and you can either put just comma -5, or you can put plus or minus 5, or you can put 2 separates. X cannot equal this and this. All right, so we've looked at adding, subtracting, multiplying, and dividing. Last goal is our composition of functions. So there's 2 ways that they can write the composition of functions. We put on the notes on the front the one form. Hopefully this doesn't crash on the video. That'd be bad. Okay. So this was the way we wrote it on the front. F of g of x is how you read that. F of g of x. But the other way that they can write that is f, it'll be an open circle g, close your parentheses, and then an x outside. So you have to be very careful when you're doing your homework, because if this were a closed-in circle, it would be multiplication. If it's an open circle, it means composition of functions. So just pay attention to the dot, whether it's open or closed. Okay? And again, literally what this means is that you're taking the one function and plugging it into the other. So we'll start off with ones that are numerical. Example 3a says find f of g of negative 5. So usually I'll rewrite it. F of g of negative 5. So what you're going to do is you're going to start on the inside. And you're going to find out what g of negative 5 is. Looking at the function, we have g of x equals x squared. So g of negative 5 would be negative 5 squared, which is 25. Usually I'll do this in my head. I don't even show work for it, because you know what negative 5 squared is. It's 25, but I'll show work for our notes. So you're going to get rid of the g of negative 5 and replace it with 25. Now we're finding f of 25. So we need to go to the f of x function and plug 25 in for x. 25 minus 2 is 23. So you're finding what g of negative 5 is, getting that answer, then plugging that answer in for f of x with the x variable. The next one flips the order. So this one is g of f of negative 5. It will get us a different answer most of the time. Start on the inside. What is f of negative 5? I heard someone say it. Negative 7. Because that is x minus 2, so negative 5 minus 2 is negative 7. So get rid of that. You do not need to show work for that part. You can do it in your head for the first one. Really, for all of them you can. And then g of negative 7 would be negative 7 squared, which is 49. All right, let's do a couple more with numbers, and then we're going to see some that have just variables, which are probably the harder of them. So start on the inside. What is f of negative 2? Someone I haven't heard from you today. What is f of negative 2? Tyler? Negative 10. That would be 3 times negative 2 minus 4. Negative 6 minus 4 is negative 10. So that's now g of negative 10. What will I get when I plug negative 10 in for g of x? Savannah? 99. Negative 10 squared minus 1. 99. Try the next one. What should we get for g of 0 when we do the inside part? G of 0? David? Negative 1. 0 squared minus 1 is negative 1. F of negative 1 will get me? Bailey? Negative 7. Again, on your quiz, I don't make you, these are usually on your note calculator part. You don't have to show any work for them. You can just do them in your head most of the time. Now the next one has fractions, but it doesn't make it that much harder because the denominator matches. Uh-oh. Go away. Okay. So this would be 3 times 2/3 minus 4. You can either think of the 3's as dividing out, or you can get 6 divided by 3, which would be 2, minus 4, which is negative 2. And then we plug negative 2 in for x in the g of x function. The last one has has a square root in it, and it's a g of function. So you basically just use the same function 2 times. So when you do the first one, that would be square root of 5 squared plus 1. What would I get when I perform that? 6. The square root of 5 squared. These undo one another to get us 6. Then we'll do g of 6. We should get 35. Ethan.
minus 1.
Oh, thank you. Good job, Ethan. So that should be 4. Which will be this 4 squared. Which will get us 15. That's what I had on my paper. Alright, now the last thing we're going to look at today, it's probably just number 5, we'll see if we get to 6, is take away the numbers and just have x's. Okay? So we have 2 functions given, f of x and g of x, and they want us to write the composite function, which is literally taking one function and plugging it into the other one. So the first one is f of g of x. So again, you start on the inside. So go to the g of x function. You're taking that whole function and you're plugging it into the f of x function for x. So that's what we did. We normally found what g of 2 was. We got a number, like 2, and then we plugged that number in for x. Now you're going to take this whole quantity, g of x, and you're going to plug it into the f of x function wherever you see an x variable. Now you need to use parentheses. So this would be parentheses 3x plus 1, quantity squared, minus 1. Taking the g of x function and putting it into the f of x. And then you need to simplify. We have a binomial squared, so we need to expand it and FOIL it. So the 2 1s, the plus 1 and the minus 1, would go to be 0. So we have 9x squared plus 6x. Domain is easy, no square roots, no denominators, just all real numbers. Now for b, I'm going to rewrite the functions out because since we already wrote on the top ones, just rewrite them over here. F of x equals x squared minus 1. G of x equals 3x plus 1. So we can draw our arrows again and not confuse you when you look back at your notes. So this time we're starting on the inside, which is our f of x function. So you're going to take this whole thing, x squared minus 1. You're going to plug it in for x in the second function. It's like almost like you're highlighting it with your cursor and like cut and pasting it like in Word or Google Doc. So you're getting rid of this x. You're replacing it with that quantity. So this would be 3. You need to use parentheses since you're plugging in a binomial. X squared minus 1. And then there was a plus 1 in my function. Distribute the 3. 3x squared minus 3 plus 1. Combine your like terms. 3x squared minus 2. No square roots, no denominators. Domains, all real numbers. Okay, the last one we will get to real quick, 6. We can skip our closures today. Different functions, same questions. F of x and g of x. And be careful, because on the homework, the book tries to trick you and they put g of x like here and f of x here. So make sure you read the functions and don't just think they're in alphabetical order. So this one we're going to start on the inside, which is our g of x. Plug that whole thing in for x. So that'll be 3 times the quantity, the square root of x plus 2 minus 4. So it should be 3x minus 4, but you're plugging that in for x. Distribute your 3. You'll get 3 times the square root of x. 3 times 2 is 6. And then you can combine your like terms. Domain. We do have a restriction on our domain. What did we say the restriction on a square root is, or any even root? What's the restriction? Now it can be 0, the square root of 0 is 0. Can't be negative. Okay, so we would say that the radicand has to be greater than or equal to 0, because it can't be negative. So the radicand is just x. So the domain is that x has to be greater than or equal to 0. While I'm passing out your homework, try B, where you're flipping the order. And then I am going to tell you guys to skip number 77 on the homework. Because it just is too long, really. It's like a polynomial of 5 terms times a polynomial of 4 terms, so you'd have to do like so many arrows. I didn't give you enough space. So skip 77, it's on the back. So for g of f of x, you should have the square root of 3x minus 4 under the radical plus 2 at the end. And there's nothing to simplify there. You cannot square root the 4. Okay, that's just it. What should our restriction on the domain be? X has to be greater than or equal to, done? Close? No? 4/3. Remember, it's radicand is greater than or equal to 0. So this would be 3x minus 4 has to be greater than or equal to 0. Add 4. Divide by 3. So that x has to be greater than or equal to 4/3 or 1 1/3. Again, make sure you skip number 77.